Alright everyone, here's the video that I tried to make in class and pressed the wrong button to make. So we get started here. We have Grace buying and selling wallets. The income received by selling the wallets is calculated by the formula I equals 30. So that's our first important piece of information right there. That she is selling wallets to, and that is her formula. Very commonly when you get the formula for income, there is no B for that, so there's no initial value. These are direct or proportional linear functions or direct variations. The next piece of information you get is the cost, and here's your cost equation as well. With these formulas, you'll notice, or with these examples, you'll commonly have dollars being given to you on one of your axes, and the items being sold, or the method of revenue being on the x-axis as well. The first thing it says is use the graph to determine the number of wallets that Grace needs to sell to break even. So what this means is it's asking where is the break even point, or where is the point where the two lines cross. This is where the profits, and there's zero profit but also zero loss. It is right here on your graph. It's where the two lines intersect. So what you have to do is you have to read on your graph. So we'll read up from 3. So I read up from, or I read, from the point of intersection. I see that our x value is 3. And then I read across from 3. And you gotta read carefully across, and it is midway between 80 and 100. Well, that's about 90. So 390 would be that point where it breaks even. What does that mean is a good question. So this means that Grace needs to sell 3 wallets, or 3 items. And in selling 3 wallets, Grace has a income and cost of $90. So that's what that value tells us. So that's what that solution tells you, is that your number of wallets produced is 3 to break even, and that right here that the dollars made and the dollars spent is both 90. So that's right here. So that tells us how many wallets Grace needs to sell to break even. Done. So I'm going to flip to my next slide just to kind of do B. All right, B. How much profit or loss does she make when 4 wallets are sold? So one method that we talked about in class was that you could read the graph. So we could read up. Then you have to figure out where our cost and our income both cross 4. And then you have to read carefully, and which can be a little bit tricky. It might not be exactly accurate as well, depending on the graph. So there's another way we can do this. It's a little bit more accurate. So we could figure out our income. Income equals 30x. Well, we know that our x value is 4 because this is our x-axis, and they've told us our x value for this situation is 4 wallets. So we'd say, what is 30 times 4 for our x value of 4 wallets, because it's the cost of $30 per wallet, and we know that she sold 4 wallets. So 30 times 4 gives us 120. So there's her income. Next, we need to figure out her cost. And cost equals 20x plus 30. Again, we look here. We have our x value still of 4, so she's going to sell 4 wallets. So the cost for selling 4 wallets is going to be $20 per wallet per x, which is 4, plus 30. So what is 20 times 4? That gives us 80 plus an additional $30. 80 plus 30 makes 110. So now we know our income, and now we know our cost. We talked about it in class, but profit equals income minus cost. So profit equals $120, which is the income, minus the cost of 110. Off those 4 wallets, she's able to make $10. Woot woot. So there's her profit in this situation. If she ended up with a negative profit, that would be called a loss, and she would be losing money on that sale. Up until selling 3 wallets, if she sold 2 wallets or only 1 wallet, she'd be at a loss. If she sold 5, she'd be getting an even larger amount of profit. So the difference between her income and her cost would be even greater, and as a result, her profit will be larger. That's example A that I took up in class. The second example talks about a firm selling its product for $20 per unit. So I'm just going to take 1 second. I'm going to circle that. So sells its product at $20 per unit. That's going to be the income. So that's good to know. And we also know that the production cost is given by the rule. So there's our formula for cost, where X is the number of units produced. So for our first example here, what we're going to do is for A, we're going to find the value for X, which the cost of production of X units is equal to the income of revenue received. This is our break-even point. So we're trying to figure out when is the cost equal to the income. So that's the break-even point. So to do that, what we're going to do is we're going to do A graphically. So we're going to use a graph to figure this out. So the first thing I'm going to do is I'm going to label my graph. It's going to be a little bit tricky for me because I don't have a ton of space. Let's see if I can move my graph up a bit, because it's just a little bit tricky to see. So I'm just going to move it up so it'll be easier to label. Okay. So I'm going to start by figuring out my equation. So I know my first equation is my income equation. So income equals $20 per item sold. So that's going to be 20 per item sold, so 20x. The next thing we know is that cost is equal to 4 times items sold plus 48. So what we're going to do is we're going to graph this. So this can be kind of tricky to determine our initial values. So I'm going to go up by single units on our X. So there's 1, 2, 3, 4, 5, 6, 7. So that's, I can keep going on my X-axis. Sorry about that. On my X-axis, I could keep going, labeling my points if I needed to, but I'll just kind of stop here at 8 items. The next thing I'll do is, because going up by ones might be impractical, I know this because I can see that I'm going up by 20s each step. So what I'm going to do is, I know that my income is going to go up by 20 each time. I'm going to use a scale of 20 for my cost. If you wanted to, you could probably even use tens, just to scale it down a bit, and I'll use tens just for the sake of showing. So I'll go by 10. That's 10 right there. 20's getting a little bit tricky to label. 30's right here. 40's right here, and I'm just going up by 10s, so it'll be a little bit easier to graph. 50's right here. 60 is right there, and I could keep going, and this is our dollars right here. And I can keep going up on our axis here to 70, but I'll stop there. Okay. So the first thing we'll do is we'll graph our income. Because it has no value right here for B, we know this is a direct variation, so we start at 0. There's our 1 point. And each step we're going to go up by 20. So our first step will be at 120. There's our first point. Our second point will be at 240, and I'm just going up by 20s each time. 360. 480. I'm just trying to eyeball that. There we go. So there's our first line. And I'll take 1 second and try to draw a nice straight line. In reality, you'll be using a beautiful ruler. You won't be freehanding on a tablet, but hey, that's not bad. So there's our first line. The next thing we'll do is, that was our income. So right there, that's I equals 20x, what I just graphed. So the next thing I'll do is I will now graph our second equation and see where they intersect. The first thing we know is, because we have positive 48, that means our first point is right about there. When I go to our first step, I'm going to go up by 4. So at step 1, my first step, at step 0, I'm at 0, 48. My next step, my first step for when one item is sold, I add 4 to get to 52. And if you have no idea how I did that so easily, in my head, and I'll just quickly scribble this over here, in my head I knew that 4 times 1 plus 48 equals, 4 times 1 is 4, 4 plus 48 is 52. For my next point, I'm going to go 4 times 2, which makes 8 plus 48, and 48 plus 8 is going to give me 56. So that's going to be my next point. I've got another point at 256. I know sorry about my comma there. My next point will be at, and I can just add 4. You notice every step along the way, I'm going up by 4. So as I go with each step, I'm going up by 4. So I'm adding 4 as my pattern. As soon as you start to see this pattern, you can start to kind of be able to fill it in more quickly. So my next point's at 3. My pen's starting to die. 60. And then my point after that will be at 464. I'm just adding 4 on each step. So what I can do is I can start plotting those points. So my next point would be at 152, would be about there. 256 would be my next point, which would be about there. My next point's at 360, there. My next point's at 464. And as soon as my lines have crossed, I can stop graphing, or I can stop plotting points. I know that this is the line of, oh, my pen's dying. C equals 4x plus 48. And if I had used a really good ruler and really being careful, I would see that my point of intersection is right here. And that point of intersection is at 3,60. And if you use a ruler and you're careful, you can easily get that. Because I'm using a stylus without a ruler on a tablet, it's really tricky for me to draw these lines as straight. And I don't even have a straight line tool. So you're going to have to believe me. If you look at the slideshow, you'll see that I graphed this out on Desmos, and it does give me a solution of 360, or 3,60. If you're what just happened, you're like, there's no way that is true. The other thing you can do is you can solve, or you can check algebraically, which is the last part. So we still have that I equals 20x, and we still know that C equals 4x plus 48. The other thing that you can do is you can also think of this as y equals 20x, and y equals 4x plus 48. So when I look at this, it's already kind of isolated. So I'm not going to try to solve by elimination. I'm going to solve by substitution, because we already have y isolated for. You have two situations where y is isolated for. So I'm going to substitute 40x into the other, or sorry, 20x into the other equation. So I'm going to take this 20x right here, and I'm going to substitute it in to the y value in the second equation. When I do that, my equation, now that once I substitute for the first time, becomes, I'm going to substitute to get 20x equals, my stylus is hating writing right now. So I've substituted my one into the other. I can now start to rearrange. So from this side, I'm going to subtract 4x. I'm going to subtract 4x from both sides. What you do to one side, you must do to the other. (20 minus 4 is 16. So that's 16x equals 48 is all that's left. I now divide by 16 to get rid of 16. I divide by 16 Wow, this is definitely not going well. I don't even know how to get this to work better right now. It's just really fighting me on every step along the way. Give me a second to see if I can get this to work any better right now, because it just is not enjoying writing. We'll see if that works any better. Over 16, there we go. So 48 divided by 16, I'll just calculate that quick just to double check. 48 divided by 16 is equal to 3. So we get that after this, I just have run out of room, that x equals 3. So there's our first point. The next thing we're going to do is we're going to substitute this into one of our equations. I'm going to choose equation A because it's really easy to substitute it into equation A, which is this one right here. So I'm going to substitute that in because it's really going to be the most simple job to do. So I'll do y equals 20x. Because we've just found x, we can now substitute our x value in right here and substitute that in. So this will be y equals 20 times 3, and 20 times 3, y equals 60. So our solution for this, our break-even point, would be 360, which is the exact same answer that we got on our previous slide. I hope that helps explain the two examples I did in class and helps you understand how to do some of the math around break-even points. Take care.